Hi, welcome back. Today we have a different goal towards the video. I shall be displaying to you a very different set of functionalities for a totally different product. Today we have a doctor assistant robot powered by an artificial intelligence system and code. This project is to make the life of doctors in the health sector much less complicated. Doctors go through problems as other human beings do. Hence, they need care and proper safety using personal protective equipment. A doctor can be scared or nervous through an emergency, which is understandable. Not having the time to get safely into a personal protective equipment can be frustrating and lead to a doctor not having the right mindset when treating a patient. This project is to tackle the problems doctors have in the health sector with the aid of a doctor assistant robot. The main aim for this project was to contain the spread of deadly diseases when doctors come into contact with patients. These diseases can be COVID-19, which is the most recent one. Other such diseases include influenza and the likes. So this doctor assistant robot helps patients and doctors to interact with one another when there's such a breakout in the country. So this is a very influential and very interesting topic. It's a doctor assistant robot with an artificial intelligence mode, with a manual controlled mode, and also a line sensor mode for extra safety in general wards and in the health sector as a whole. Stay tuned, and this is a glimpse of the code and the video as to how it looked to a custom ward that was built to integrate and fit this purpose of this robot. Start off with command number 1. We have 11 commands there. So we'll use the switcher case, which is in the main file, to switch between each command that can be selected. So we're going to be using the left button, the right button, the enter button to scroll through the menu. The Linux-based operating system on EV3 brick does not assign the buttons automatically. You have to assign them. You have to give them a state. For example, the left button on the brick, which is supposedly be the D button. So this navigates up the menu, while the right navigates down. So the enter button confirms the state. This is where the main code is. So the main code has, again, the libraries that were imported for the required operating system and the brick to run. So these are the different menus that are there. The 11 commands is from parking to serving, serving to entrance, bed 1, bed 2, bed 3, bed 4, bed 5, bed 6, exit to drop off to parking, and the line sensor mode. So the left, we are assigning the variables from the libraries, which are the large motors. There are 4 types of inputs for the motors. There's A, B, C, and D. So we're only using output A and output B, and we've assigned them to the left motor and the right motor, and then the sound it makes. So the next one will be the wheels drive, and this is for the gyroscope for the turning. So it shows that a 90-degree turn can be done with the gyroscope. Precise plus and minus 3 calibration for the drag and lag for the gyroscope. And this is for the drive. This is the wheel diameter that we've taken, the circumference, and then the rotations as to how many rotations the robot will do per the motor. And then the function for stop. So this will go. DAR is a doctor assistant robot. We made it as a variable to be easily understood. So there's the global thread 1 check, with the thread 2 check, and there's the running thread check. So this is to monitor T1 or monitor the current thread that is running. There's thread 2 check, which monitors the distance sensor, and then the global variable, which monitors the. So we start off with the parking to serving. So I'll give an example. So the parking to serving thread check 2, if it's false, the motion sensor is not running. If it's true, the motion sensor is active. So once the motion sensor is active, it will run the required functionality that is told to reverse at 30, the speed of 30, and for 500 millimeters. It continues the processes until the last one. So this is linked to the perseverance process, which is the last one for the initialization for each of these functions to work. So for example, process 1 will start. So if it's true, for the subsequent process of T1, it will activate the thread, and then call the functions from parking to serving to start. If it's false, it prevents a repeat of P1. This is less than 20 centimeters, or it will give feedback. Tension, I am now manually controlled. So this is a feature that I added, tried to make the robot more responsive.
Bad one request. Hello. I have arrived at the pickup zone. Please drop a package for the patient. Thank you. I shall be waiting for 15 seconds. I shall now be leaving. Hello. I am at your service. Please drop or pick up your package. Thank you. Recover well. I shall be with you for 15 seconds. Hello, I have now exited the main ward, going to drop-off zone. Detected. I am now manually controlled. Emergency stop. I am now manually controlled.